Today, we are going to embark on a journey into one of the greatest mysteries in human history. For centuries, countless scientists have pondered this question, carried out endless studies, and sought to make progress in solving it. Think about it for a moment. We all share the same questions in our minds. Where did we come from? How did life begin? And are we alone in the universe? Today, we'll dive deep into exactly these questions. We'll explore the origin of life, how it may have emerged on Earth, and whether life could exist on another planet or celestial body. And by the end, perhaps you'll find yourself thinking the same as I do. Maybe we are not alone in the universe, after all. So let's start at the very beginning. One of the most studied topics in science is the origin of life on Earth, known as abiogenesis, the emergence of life from non-living matter. Sounds incredible, doesn't it? Lifeless rocks, soil, water, and gases somehow coming together over time to form living cells. Yet science tells us this is possible. But how? First, the building blocks of life must form: amino acids, nucleotides, fatty acids. Think of them as the alphabet of life. Then, these small building blocks combine into larger molecules like proteins, RNA, and DNA. Eventually, they become enclosed within membranes and evolve into the first cell-like structures. One widely discussed hypothesis here is the RNA world hypothesis. It suggests that life first developed not through DNA, but through RNA. Why? Because RNA can both store genetic information and catalyze chemical reactions. That's a critical dual role. But how did RNA itself first emerge? That's still a big mystery. Another theory proposes that life began in hydrothermal vents at the bottom of the ocean. These vents spew hot water and minerals, creating an environment rich in energy gradients. Many scientists believe these conditions were perfect for the birth of life. Energy, minerals, and chemical diversity all in one place. So perhaps life began not in a warm little pond, but in the dark, pressurized depths of the ocean. Now let's ask, what conditions are needed for life to emerge anywhere? First of all, water. Water is one of the best solvents in the universe, facilitating chemical reactions and transporting molecules. That's why scientists, when searching for life elsewhere, always ask, is there liquid water? But water alone is not enough. Elements like carbon, nitrogen, phosphorus, and sulfur are also essential. They make up proteins, nucleic acids, and cell membranes. Add to that an energy source: sunlight, chemical reactions, or geothermal heat. Without energy, there is no metabolism. And of course, time. Life didn't emerge overnight. It took billions of years of chemical evolution. Now, hold on tight, because here comes the most exciting part. Is life unique to Earth, or could it have sprouted elsewhere in the cosmos? This is where Europa, Enceladus, and Mars come into the picture. Let's begin with Europa. Europa is one of Jupiter's icy moons. Its surface is covered in thick ice, but beneath it lies a massive ocean. In fact, scientists believe it may contain more water than all of Earth's oceans combined. Imagine that for a moment. An ocean, a source of heat and mineral interaction, the three key ingredients for life. NASA is preparing a mission called Europa Clipper, which will explore the moon's surface and magnetic field to gather more data about the hidden ocean. If hydrothermal vents exist under that ice, just as they do on Earth, microbial life there could be entirely possible. Picture it: alien life forms dwelling in the dark oceans of another world. That would be the single greatest discovery in human history. Enceladus, one of Saturn's small moons, is just as fascinating. It has icy cracks on its surface that shoot out giant plumes of water vapor and ice into space. When NASA's Cassini spacecraft passed through those plumes, it detected organic molecules. So Enceladus doesn't just have water. It has the building blocks of life as well. This was a groundbreaking moment in space exploration. Scientists are now planning missions to return to Enceladus, to sample those plumes more directly. Imagine capturing material ejected straight from an underground ocean and analyzing it for life signs. It could be the easiest way we'll ever have to search for extraterrestrial life. And then we have Mars. The red planet has been the focus of life-hunting missions for decades. Today, its surface is harsh, but in the past, it had lakes, rivers, and maybe even seas. NASA's Perseverance rover is currently studying Martian rocks and has already discovered organic carbon compounds and minerals that, on Earth, are usually linked to biological activity. This suggests that microbial life might once have existed on Mars, but to confirm that, we need to bring the samples back to Earth for detailed analysis. That's why the Mars Sample Return mission, being developed by NASA and ESA, is so important. If successful, it could reveal fossilized traces of ancient Martian life dating back billions of years. But let's consider another possibility. Maybe life didn't start on Earth at all. Maybe it came from somewhere else. This idea is called panspermia. When massive impacts launch rocks into space, some may carry microorganisms hidden within. If those rocks land on another planet, like Earth, the microbes might reawaken and begin life anew. Supporting this theory, scientists have found amino acids and organic compounds in meteorites that fell to Earth. And we know some microorganisms can survive for short periods in space conditions. So, interplanetary travel of life is not entirely impossible. But here's the catch. Let's assume life came to Earth from Mars. That only leads us to another question. Then, how did life begin on Mars? In other words, panspermia doesn't solve the ultimate question of life's origin. It just moves it somewhere else. We still end up back at abiogenesis, life from non-living matter. My dear friends, as you can see, the question of life's origin is not just scientific, it's also deeply philosophical. Who are we? Where did we come from? Are there others like us out there in the universe? These are the questions humanity has always asked. Perhaps one day, we will drill through Europa's ice and find microorganisms swimming in its hidden ocean. Perhaps we'll sample Enceladus's plumes and uncover biological fingerprints. Or maybe, when Mars's rocks finally arrive on Earth, we'll see undeniable traces of ancient microbial life dating back 3 billion years. For now, all of this remains uncertain. But with each discovery, the possibility grows stronger. Our mission is to keep exploring, to keep questioning, and to keep seeking answers. Because maybe, just maybe, we are not alone in the universe. That's all from us for today, friends. We're already preparing our next video, so don't forget to subscribe to our channel, like our videos, and share your ideas in the comments for new documentary topics. Every step in space, science, and technology keeps us curious and inspired. Until the next video, take care and goodbye.